For our next speaker, we're delighted to have Juba Ziani from Georgia Tech, speaking about information discrepancy and strategic learning.
Yeah, so hi everyone. So first thing I want to say about this talk is that this is joint work with Yahav Bechavod at Hebrew University, Chara Podimata at Harvard, and Stephen Wu at CMU. By the way, I just want to give proper credit on the slides because Yahav made those slides, and I haven't done any actual work on this, so just so that you know. But yeah. So anyway, kind of like in this paper, what we're doing is like we're kind of like looking in the strategic learning setting, and we're looking at a setting in which, you know, this setting is going to involve some decision making over human individuals, and those like individuals are going to prefer some outcomes versus others. So if you look at like loan decisions, for example, well, as person who's going through the loan approval process, you'd rather just get the loan accepted than rejected, right? So here, the point is like you actually care about the outcome of your mechanism, and you really want to say, as an individual, you really want to receive a more favorable assessment here. And one way that you can try to do so is you can try to act strategically and to modify your features in a way that are going to lead to you getting better outcomes. So what you can do is, you know, there is some deployed policy, pi, which is like some policy that tells you whether you're going to get a loan or not, and you're going to fit your features in this policy. You're going to fit your features x right here. But so x, you can see them as your true features, and you can try to decide to invest some effort to change your features from x to x prime. And so now what you're trying to do is you want to change your features in a way that's going to lead to basically you having there's a tiny bit of formalism here, but all this says is like when you change your features from x to x prime, you'll get better decisions. But at the same time, you know, you're going to incur some cost from changing your features from x to x prime, and you know, you kind of like want to trade off how much you're going to improve your outcomes versus, how much you're going to improve your outcomes versus how much effort you're going to invest into changing your features. So you know, that's kind of like the standard strategic classification setting so far. But one of the main assumptions of this strategic classification setting is generally that everyone in the problem, every single agent who's reacting to the classifier actually fully understands the classifier and fully understands the deployed policy. And so here what we're trying to do in this paper is we're trying to move away from this assumption because it's often going to be the case in reality that the policy is not accessible. Many companies have policies that are black box proprietary models, and you're actually never going to see the details of how the policy is going to work, for example. So what can you do then? Well, you don't get to see the policy itself, but you actually might be able to see labeled examples from other people that went through the classifier, or like some explanation of the classifier. And seeing those samples and seeing those examples, you might be able to actually reason about what the classifier actually looks like. And so, once again, what we are doing in this paper is we're focusing on a strategic learning setting in which people don't really know a priori the classifier or the decision rule. And what we do is we're assuming that what they're going to do is they're going to learn from peers. So they're going to be seeing samples from their peers. They're going to be seeing the features that their peers have and whether they actually got a positive or negative decision and try to recover to some extent the decision rule from this. So now we're really interested in this setting in looking at fairness in this setting because you could imagine that people from different populations are going to have access to different information. So people are going to see information from their peers, and you know, their peers might have very different features in different populations. So what can happen here is that you end up in a setting in which different populations, like here I have 4 populations on this slide, and different populations are going to have different features, and so people in different populations are going to recover different models. They're going to have different information about the true classifier. And so really what we're looking at in this paper is we're trying to understand what the effect of those information disparities about the true classifier, and like those information discrepancy, how they're going to affect different subpopulations, and how they're going to affect the ability of people in different subpopulations to improve and change their features to fit the classifier better. So first, I just want to go very quickly through some of the experimental results that we have. And so what we did here is we looked at the adult data set. And what's going on in this data set is pretty much the data set has information about how agent features such as age and country and work class indication and race are going to map to some income level. And what we're doing here is we're basically dividing our population. Yeah, 1 minute, okay. We're dividing our population in different subgroups, and we're trying to understand how those different subgroups are going to understand the classifier and how they're going to respond to it. And we're trying to predict how much they can change their features so that their income is going to look good as an output of this classifier. And what we're showing is like in the setting, as you divide people in subgroups, there's going to be huge disparities in how much they're going to be able to improve and how much they're going to be able to improve their predicted income level, depending on how much information they actually have about the classifier. And we have a few interesting insights, but like one of them is that if you don't understand the classifier well, you actually might be able to do something that's going to hurt yourself and make your income actually look worse than it is when you go through the classifier. And the other is just, if you just look at this graph, you can see that there actually are huge disparities in this data set across different subpopulations. So these are the main experimental insights of the paper, but we just want to point out like super quickly that we also have theory about this. And so we have like some theories kind of like making a connection between the information that's going to be available to different subpopulations and the ability of individuals to improve and disparities in their ability to improve. And we do such like theoretical characterizations for several possible definitions of disparities. One of them being do no harm, which means that basically, can you, by having incomplete information, actually make a decision that's going to hurt your outcome and utility? The second one is equal improvements, which is basically saying, can the two populations have equal improvements in how much they can improve their predicted income in a setting? And the third one is about whether they're exerting their efforts in a comparable way, and whether one population is exerting much more effort than the other one to get to the same decisions. And that's pretty much all I wanted to talk about today. So thanks a lot for coming and listening. Yeah.